Welcome to video 3 lesson. This lesson is about to differentiate vectors and scalars. I also explain two important methods how to combine vectors. Here is a table split into two with all slides and descriptions of the content covered in this video. If you want to review only past questions from paper 1 exam, please slide the video bar to stop on the slide number you want to watch. Slide 1 illustrates the difference between distance and displacement. This student needs to walk to the bus stop marked with an X. If he walks around this landscape and add all small lengths throughout this path, the total length is called distance. However, if he walks in a straight line from his starting point to the X mark, we call this length displacement. Displacement definition is the distance moved by an object in motion, in this case, this student, in a particular direction, measured from a fixed starting point. Displacement requires a direction. For this reason, is a vector quantity. Now, let me say this student wants to calculate his speed or how fast he walked. Then he would have to record the distance and the time he walked to calculate his speed. Speed is the ratio between distance over time taken. Because this quantity does not require direction, just the values of distance and time, speed and distance are scalar quantities. Now let me say this student wants to calculate his velocity, which is the same as how fast he walked. Then he would have to record the length from his start point to the X mark as a straight line. He also needs to take the time he walked. Then he divides the displacement by the time taken. Because this quantity requires at which direction he measures the length. Velocity and displacement are vector quantities. Likewise, a moving car speed can be displayed on the speedometer. Again, no direction is required. Because the speed on the speedometer changes frequently as we look at the speedometer on the dashboard, we say this is the instantaneous speed. In this box, you have the formula and description for speed. So speed is the distance over time taken. In words, speed is the rate of a distance over the time. Speed is a scalar quantity. Direction is not associated with speed, also with distance. To calculate the velocity for the same moving car, we'll need a map to trace its location from start to finish destination. Also, the time taken for this straight trajectory. Because this straight length needs a reference or direction, this information needs to be specified. Here is a formula and velocity description. So velocity is changing displacement over time taken, and velocity is a vector quantity. Direction is associated with velocity and displacement. In summary, to calculate velocity, we need information about displacement, and to calculate speed, we need information about distance. In both cases, an object, person, car, ball, etc., must be in motion, and time must be recorded or estimated. Displacement and velocity are vector quantities, and speed and distance are scalar quantities. This table shows a list of scalar quantities used in physics: distance, speed, energy, time, mass, density, electric charge, pressure, temperature, volume, and area. This list on the right shows vector quantities used in physics: displacement, velocity, momentum, acceleration, and force. Exam tip: questions about scalars and vectors are usually straightforward. I would suggest memorizing this list of scalars and vectors quantities. First example about a scalar and vector from past paper 1 exam. The power produced by a force moving an object is given by the equation shown. Power is work over time, and work formula is force times displacement. Which quantities are scalars and which are vectors? To organize my thoughts, I'm using this table to sort all physical quantities as vector or scalar. Power, work, and time. From my list presented on slide 3 are scalar quantities. Force and displacement are vector quantities. Looking options from A through D, the best answer for this question is option B. Second and final example about scalar and vector from past paper 1 exam. This is a straightforward question. If you have memorized my list, you can easily answer this question in 1 second. The question asks which quantity is a scalar. From the options here, only energy is a scalar quantity. Acceleration, force, and momentum are vectors. Basic calculations with scalar quantities are pretty simple and straightforward, but calculations with vectors are quite different. Vectors are represented by an arrow. The arrowhead indicates the direction, and the length of the arrow indicates the magnitude. Vectors can be combined in 3 ways: TiptoTail method, triangle method, and parallelogram method. In this lesson, only TiptoTail and triangle methods are shown. Here how it works for TiptoTail method. Without changing the size and direction of the arrow, connect the tip of the first arrow on the tail of the second arrow, like this. Now we are going to draw an arrow connecting the tail of the first arrow to the tip of the second arrow, like this. This arrow is the resultant vector. The tip of the resultant vector must be connected to the tip of the second arrow. Let's do one more example. So here is A, but A in this case is inverted. So because of that, we are going to place a minus sign on A to indicate that the direction is being flipped. Again, without changing the size, but this case we change the direction, but we are indicating with this minus sign. I'm going to connect the tip of the first arrow with the tail of the second arrow. And now I'm going to draw the resultant vector, which comes from the tail of the first vector to the tip of the second vector. And notice here, the resultant vector tip align with the tip of the second vector. So this is my resultant. Now look at the difference. The resultant R is B minus A because I changed the direction. Let's do one more example. So here I keep the original direction of A, but I'm going to flip the direction of B. So I'm aligning tip to tail. And now I'm going to draw the resultant. So the resultant is from the lonely tail to the lonely tip, if you can say this way. And here is R, the resultant is A minus B because B is inverted. So with two vectors, we can have three different ways to combine them. So the resultant vector combination is known as the resultant vector R. Here are the TiptoTail method steps. Step 1. Without changing the size and direction of the arrows, connect the tip of the first arrow on the tail of the second arrow. Here a note. If the direction of a vector is flipped, add a minus sign on the vector quantity to indicate the opposite direction. Step 2. Draw an arrow connecting the tail of the first arrow to the tip of the second arrow. Step 3. This arrow is the resultant vector. Step 4. The tip of the resultant vector must be connected to the tip of the second arrow. Example of TiptoTail method from paper 1 past exam. Vectors P and Q are drawn to scale, which diagram represents the vector P plus Q. So, without changing the size and direction of the arrows, I'm going to connect the tip of the arrow P to the tail of the arrow Q, like this. Now, I'm going to draw an arrow connect the tail of the first arrow to the tip of the second arrow, like this. So this is my resultant vector. Now I'm going to look the options A, B, C, and D. Each one look like this. And obviously is option A. Another question, use TiptoTail method for vectors. P and R are coplanar vectors. Coplanar vectors are vectors that are lying in the same dimensional plane. Here is an illustration. So this vector, the blue one, is not on the same plane. So this vector, the blue one, is not coplanar. So let me keep going with the question. So if x which is equal P minus R, which diagram best represents vector X? Okay? So our focus here is on vector X. So let's see what's going on. First, let me get the vector P and the vector R, because here we see negative, need to be flipped like this. Now, the resultant vector I need to draw from the tail of this vector to the tip of the next one, like this. So this is my resultant vector X, which is P minus R. So which one looks like the green one? So we look at the option. This inverted, no. This no, this no. This is not even indicates an arrow here. So my best answer is A. Here is another example of vector addition using TiptoTail method. The diagram shows two vectors, x and y, drawn to scale, x and y. If x is equal y minus z, which diagram best represents the vector z? And here are 4 options. So the first thing you need to do is, with this given equation, x is equal y minus z, we need to rearrange in terms of z. So here is x minus y is equal minus z. So I want in terms of z, and I want to get rid of this minus sign. So I multiply both sides of the equation by minus 1. So my z is equal y minus x. Okay, so what that means? That I'm going to remain y as it is, but I'm going to flip x. So this is y, and this is x being flipped. Now I'm going to draw my resultant from the tail to the tip, like this. And this is my z. So each option best represents the green arrow, should be A. Two forces act on a circular disk as shown. Here is a force to the right, 4 newtons. This is a force upward, which is 3 newtons. Which diagram shows the line of action of the resultant force? Here we have 4 options, and all of them shows a resultant of 5 newtons. So let's go through steps. So this blue tiny arrow represents the 4 Newton force, and this red arrow represents the 3 Newton force. So I'm going to use TiptoTail method, and I'm going to draw the resultant from the tail to the tip, like this. And what is the value of this vector? What is the value of the resultant? How can I calculate? Since those values are provided here, 3 and 4, and this is a right triangle, I can use Pythagorean theorem to calculate this resultant, like this. So the resultant square is 40 squared plus 3 squared. So when you solve and square root, your resultant is 5 newtons. So now you see 5 newtons on every single answer. So what about the direction of the resultant force? So the direction of the resultant force is showing right here, from the center to northeast. Okay, but I see option A and option C pretty similar. So how will be my thought process to determine which direction is correct? So 4 and 3, they were provided these values. So I'm gonna use the tangent of an angle right here. on this corner of this right triangle, which is the opposite, which is 3, over adjacent, which is 4. Then I'm going to calculate this angle as the inverse of the tangent of 3 over 4, and I will have an angle of 37 degrees. So let's see if I can work with this. 37 degrees. So if you look, this is a quadrant. So half will be 45. So is less than 45. Okay, what about C? Again, is a quadrant, and this is kind on 45. So because of that, I can use this value to select my answer, which is option A. Now I'm going to teach you the second method to combine vectors, which is the triangle method. So just like the tip-to-tail method, we have some steps to follow. So here are A and B, the original vectors that we use for tip-to-tail. So the step 1, we are going to place all these vectors on a XY grid. So this is A, is already aligned with the X direction, B is not. So we have to find the X and Y component for B. So here is the Y component, and that will be, this is the Y direction, and this, the red one, is the projection of B on the X direction, which we are going to call BX. Notice that now we have an angle that is formed between B, the vector B, and the X direction. Likewise, we are going to have a component on the Y direction, which is the BY. The second step is to calculate B, X, and Y components. And for this, we are going to use trig function. So BX is B cosine of this angle theta. Now, why I'm using cosine, remember, the BX is close to this angle. So close rhymes with cosine, kind of. That's an easy way to remember. And BY will be, because it's away from this angle, so then will be B sine of theta. The third step is to calculate the resultant for each X and Y directions. So here on the X direction, I have two vectors. I have A to the left and I have B to the right. So if I use right as my positive reference, so I can say that BX minus A will give me the resultant on the X direction. On the Y direction, I just have BY. I don't have any component for A because A is aligned on the X direction. So Y direction, I just have BY. Let's go to step 4. Now we are finally calculate the resultant. But how? We are going to use Pythagorean theorem. So the R squared will be equal to the final component for the X squared plus the final component of the Y squared. So these are the 4 steps to follow when we use the triangle method. One note here, I moved this slide that originally was grouped with tip-to-tail method, and I moved to the triangle method because it's easier to explain. So here is what happened. The arrow represents a vector R. Which diagram does not represent R as two perpendicular components? So remember that the vector B, when I was explaining the triangle method, because it's not aligned with X and Y direction, I have to break into its components on the X direction and Y direction. So I'm going to use the same approach to answer this question. For example, Here is, I'm going to highlight the vector r as this red vector. As you notice, I didn't change direction or magnitude. Now let me work on question A. On question A, I'm going to draw this line here, just like I did with this B vector and the other line here, and I'm going to draw the component right here. So as you notice, that is pretty similar. So that will be the resultant between those two vectors. Let me keep going. Now for B, I have this line here and this line here, and now I'm going to draw the resultant, and also is very similar. I'm going to question D, so I'm going to draw this and this. It's like that you are closing a box. And now I'm going to draw the resultant vector, which is this, which is also pretty similar with the vector R. Now let me do the option C. Option C, I'm going to draw this line here parallel to this, and I'm kind of close this box a little bit, not very done, but I'm going to draw the resultant, which is this. Now as you notice, the direction of this vector is not the same direction of the vector R that I'm looking for, this one. So here the question is, does not represent R. So that will be option C. Here is another example of paper 1 past exam to find the magnitude of a resultant force, and I'm going to solve this problem using the triangle method. Two forces, each of 10 newtons, act on a point P as shown. The angle between the directions of the forces is 120 degrees. What is the magnitude of the resultant force? So following the steps for the triangle method, first we are going to draw an XY grid right here. The second is, okay, so the 10 newtons is aligned with X, but this 10 newton is not. So we need to calculate the components X and Y for this force. So here we have the X component of 10 newtons, and here we have the Y component of 10 newtons. Notice that I could move this red arrow to align with the Y direction, but I want to close this right triangle. Now I need to determine this angle right here. So the whole thing is 180 degrees. Minus 120 gives me 60 degrees. So now that I have this complete right triangle and all the information, I can use sine and cosine to determine the components. So x is 10 cosine of 60 because it's close to the angle. So close, use cosine, kind rhymes, which is 5 newtons. And y is 10 sine of 60 degrees, which is 8.6 newtons. The next step is to determine all the forces acting on x and y direction. On the x direction, I have two forces. I have 10 newtons to the right, and I have x to the left. If I want to use the to the right as a positive reference, so then my forces in the x direction, the net force will be 10 newton minus the value of x, which is 5 newtons. So the result is 5 newtons. At the y direction, I just have 1, which is the component of this vector, which is the y. So 8.6 newtons. Great. So what I do with this information? Now I'm going to draw another triangle that is nothing to do with this one. In this triangle, the components are my 5 newtons from my x resultant and my y vector, which is 8.6 newtons. So I want to know the resultant of those two partial vectors. So then I have to calculate the value of r. So I'm using Pythagoras theorem because this is a right triangle and this is the hypotenuse. So I can do this. R squared is equal 5 squared plus 8.6 squared. And when you square root this, I will have 9.9 newtons or 10 newtons, which is my option B. Another question using vector triangle method to calculate the resultant force. Two dogs pull a sledge along an ice track as shown. Dog X pulls with a force of 200 newtons and an angle of 65 degrees to the front edge of the sledge. Dog Y pulls with a force of 120 newtons and an angle of 45 degrees to the front edge of the sledge. What is the resultant force? I want to rephrase this. What is the resultant forward force on the sledge exerted by the two dogs? So first, let me identify both forces here. So this is the 200 newtons with the red arrow, and this is the 120 newtons or this in this blue arrow. So now I'm going to draw the X and Y grid. So this is Y, this is X. Now I'm going to project this red arrow, which corresponds to 200 newtons, to this X direction, because the problem is asking the forward force. So I'm going to project, and this is what I have, and I'm going to call this force X. Now for this one, I'm going to project, and I'm going to call this force here Y. Please don't get confused. It's not Y direction. I'm just calling the forces X and Y just to simplify calculation. Now we need to determine this angle. So the whole thing here should be 90 degrees from the beginning of this tracing line up to the red arrow. So 90 degrees minus 65 is 25 degrees. Likewise, this is from the trace line to the blue arrow. I have 90 degrees. 90 degrees minus 45 is 45 degrees. Next step is to calculate X and Y components here. So my X is 200 times cosine of 25 degrees, which is 181.26 newtons. For this Y vector, again, this is not Y direction, it's just the name of the vector. This Y vector here is close to 45, so again, I'm using cosine. So Y is 120, which is the value of this force, times cosine of 45, which is 84.45. So because both vectors, X and Y, are at the same direction and both are moving forward, I'm going to add them. So now forward resultant is X plus Y, which is 266.11 newtons. So the answer that is closer to this value is 270 newtons. One more example using vector triangle method to calculate this time velocity. A particle has velocity v at an angle theta to the horizontal. The components of the particle's velocity are v sub v upwards in the vertical direction and v sub h to the right in the horizontal direction as shown. What are expressions for the magnitude of v and the angle theta? To solve this problem, I enlarged the picture of the original picture that was giving this problem. And what I did here is I close right here, just draw a very fine line to show that I can form here a right triangle. So my next step is to close this right triangle, and I'm going to move my vertical velocity right here. And now I'm going to use Pythagoras theorem to calculate the magnitude of V. So V here is the hypotenuse, and VV and VH are the sides of this right triangle. So I can use V squared is equal VH squared plus VV squared. So I have to square root both sides. So then on the other side, will be the square root of VV squared plus VH squared. And I have here, for the magnitude, I have option A and option B. They are correct. So now let's look at the angle. How to determine the angle? To determine this angle in terms of VV, VH, and data, I'm using tangent, because tangent of this angle is the opposite over adjacent. And to calculate this angle here is the inverse of a tangent of VV over VH. So now I have my correct answer, which is B. This is the last problem of this video. The diagram shows a force F. P is the horizontal component of F at an angle theta to F. So here is a diagram. Which graph best shows the variation with data of the magnitude of P? So when we look at the four options, all of them on the y direction we have P, which is the component, and at the x direction we have the angle that ranges from 0 to 90. Why not make a table that data ranges from 0 to 90 with 10 increments, 10, 20, 30, and it's important that you know the component P is F cosine of data, because the component P is close to the angle, so we are using cosine. Cosine close, remember? Rhymes. Okay, so now I'm going to do is I'm going to use my calculator, and I'm going to type 0 degrees, cosine of 0 degrees, cosine of 10 degrees, and so on, and see how much it will affect the value of P. So cosine of 0 is 1. So 1 here, so P is going to be equal to F, the maximum value. So if you look at the table here, for when data is 0, P will be maximum. So option A look promising, option B and option C is definitely wrong. And now we have option D as well. P is maximum value when data is 0, because cosine of 0 is 1. Okay, let's keep going. For 10 degrees, P will be 0.98 F, pretty close to 1. For 20, 0.9. For 30, 0.86. So as you see this complete table here, the beginning from 0 up to 30 degrees, the value of P is pretty close. For 0 is maximal, 10 is 0.98, 20 is 0.9, 30 is 0.86. So here in this option A is the line, the curve is pretty steady. This one here is a drop, so does not show the steady variation of P with the increment of the angle. So the correct answer for this question is option A.